how can we tell the CPK of an absolutely new product? Well, that is a tricky one. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's video, it is an attempt to answer a viewer question about CPK, and specifically, if you have a totally new product, how can you determine the CPK? Now, the not so nice answer is, well, you can't really just make the product, then test it, and then you can get the CPK. This is not a very satisfying answer, is it? And it also doesn't have to be that strict. Now, the pure and final CPK, I will guarantee you can only get after you've started making the product. In fact, I think you will probably not even be able to do this during product testing, because when you're doing test runs, then you've got all your technicians there, it's all new, lots of attention, so there is on the one hand the chance that your machinery doesn't work, but most likely you've got everyone there really fixed on fixing the settings and keeping everything stable. So generally, it's my experience that after your initial production testing, when you start your first production for real, CPK goes down a little bit, usually. But it depends, of course, on how stable your factory is. Now, can you already predict it? Well, yes, to quite a big extent, you can actually get a good sense of what your CPK can be. Now, I will say you will probably get closer to the CP than the CPK, because where can we center is a bit of a difficult one, but at least it will put bounds on it. Now, for that, we should first check the CPK formula. Let's just look at it again and see what do we need. So for that, we need to check what is the lowest of the two spaces that we have. But to know that, you need two things. You need those lower and upper specification limits. So if you do not have specification limits for your new product yet, so your customer hasn't put any specification limit up, or it's your own technology department, but if you don't have them, you cannot calculate CPK. You simply cannot, because it is about the capability of reaching specifications. So without specifications, forget it, you are not calculating CPK yet. But apart from the bureaucracy, that generally is one of the easier things to get, right? Because at some point in the design process, you will have your specifications and you will put them there. So those are quite okay. Then the other part is, where actually is the middle? And let's make that a green one here. Where is the middle? And that one, that's the reason why I just said we're probably going to be calculating CP, not CPK, because that one is going to be very difficult. But here you do the same thing we'll be doing for the next part, and that is check very similar processes that you already have in your factory. Now, if you are putting up a greenfield factory, you can do a literature study, but you're probably not going to really do much with the CPK. You can only get sort of the industry standard, right? That's what I meant with a literature study. But if you are already making cables and you've been making all kinds of plugs, you know what your CNC machines can do. You know how accurate you can get the plugs to be within the specifications. So you have a pretty good idea if you are also generally on a low or high side, how much you are off center. You know these things from your other processes making similar products. And that is also how we will get the next one. So this is a bit of guesswork, but the next one that we always need is to get that sigma, right? The standard deviation. So for that, we check basically the spread divided by 6, but there are better ways of getting the standard deviation. But we want the standard deviation of a process that we know that is similar, and we plug it into the formula. And with this, we will get a sort of an upper bound for how good the CPK can be. If we assume that it is almost in the middle, but then we basically make the assumption of CP, right? Because CP is just the range of these two minus the divided, by 6 times the standard deviation. So then what you do is you just see how often does it fit in, even if it is outside of specs, doesn't matter. If it can fit in, it will fit in a CP calculation. Here, generally I would advise to assume that you are slightly off-center maybe, but not by too much, unless your current processes are all going off-center by quite a bit. If that is the experience you have on your machines and on your current cables, your current plugs, whatever you are making, then also make those same assumptions. Because this system, it'll use your current process and say, well, we've been making a 5mm plug before, and when we did that, our CPK is around 1.3, so if we're making this new 4mm plug with the accuracy of our machines, the standard deviation in the process, but lower specs, it will probably be slightly lower. And that is how you estimate. So no, we cannot calculate the CPK until we have real production, but you estimate what can we expect. And of course, saying it's a 5mm plug, that is not going to be the spec, right? The spec that we want is, it has to be 5mm plus or minus 200th of a millimeter. And that plus or minus 200th, that will be our specifications. So there's a good chance when you make a smaller plug, you can still hit those same specifications, but it will generally be a little bit more difficult. So that's why a small change. So basically, getting similar products to estimate the standard deviation that your new process will have and plugging in the specification limits of this new customer, this new product, that will give you a good idea of where the CPK will be. Now, of course, the tricky part here is the process, not so much the specification limit. So if you want to use this idea to have a new customer, so you have an existing product line, but you've never been too tight on it because your customers were not putting very tight specifications, but you know what CPK you have there, especially you know what standard deviation. And then there is this new customer that comes along and they ask for much tighter specifications. And your management asks you for an advice, can we do this or not? They are asking half the spec range and a CPK of 1.6. And then you can go to calculate and you can just plug in that company's specification limits in your existing data that you have on your process. Say, ooh, with those specification limits, we now have a 1 CPK. That's very far from a 1.6. So we're probably not going to be able to make that within due time, within a short amount of time. We can get it up because we haven't been focusing on it, but getting it up by 2 whole steps, so from 1 to 1.3 to 1.6, that is quite an ask. Or if you're already doing something like 1.3, 1.5, you can say, well, yes, we can probably manage this. That is how you can use it for a new customer that wants the same product. If the product changes, the more similar current products you have, the better you can make the estimation. But again, to really calculate CPK, you need to make the product. There is no guaranteed way to calculate, pre-calculate a process's CPK. Now, you probably didn't like the answer itself, but if you did like the explanation, hit that like button. And also, this was a viewer question. I like answering viewer questions, so please, if you have any questions on CPK, process statistics, or continuous improvement in general, put them in the comments on this video or any other video. Let me know. Another ask is, if you come across different videos on YouTube and you think that would be something nice for Tom or for my audience, link me. Use that @mention symbol, link me in their comments. I would also myself like to discover other channels with the same type of nice and good content on Lean, on Six Sigma, on our world of industrial improving. So please do that for me. For now, I wish you the best of luck improving your processes' capabilities, and as always, don't forget to enjoy the continuous improvement process.